name is Werner. Welcome to the BarryBot 3D channel. Well guys, I'm going to step a little outside of my norm and not talk about 3D printing. But after talking to many of you, it's overwhelming how many of you want to follow along with my wire EDM build. So that's what I'm going to do. I'm going to put together a video series pretty much going through every step of the process. And this is something that's been near and dear to my heart for a long time, and it just really wasn't quite feasible. I mean, to make a production type machine, something that can really make good parts and be reliable, until a few years ago. So I'm going to go ahead and take you guys along for the ride, and I think you're going to find it extremely interesting. You can see here's a whole stack full of parts that are being cut in a single pass. That's the neat thing with EDM, is you can do things that no other machine can do. And you can do inside radiuses that are just unbelievably tight. And the capabilities of the EDM are really amazing. You know, if it's metallic, it'll cut it. Doesn't matter if it's titanium, aluminum, copper, brass, Inconel, tungsten. It just cuts right through it. It doesn't really care. Another great benefit is that it doesn't put any distortion in the part because it's a zero contact cutting. So it's really beneficial in that respect. Here's a finishing pass on a part, taking it to a really fine finish. You can see in this example, this is a 10 by 10 millimeter square that's cut out of 2 inches long and just cut beautifully out of a piece of aluminum. Here's another example of a very small pendant that's just being cut in half. My buddy Ben over at Applied Science allowed me to have a few images and clips of some of the work that he's done using EDM. He's actually been EDM drilling and has really done some really neat work with a DIY machine that he's built. Shows a lot of examples of cutting just unbelievably hard to cut materials. Tungsten, carbide, graphite. He's got just about everything in his mix of things that he tried cutting. Even a neodymium magnet. If you guys haven't subscribed to his channel, you definitely should check it out. He's not only a super cool guy, but he works on some really great projects. It's funny, Ben said that he was walking around his shop looking for anything and everything metallic so that he could try drilling through it. Here's some images of some really great items. Look at that, a carbide burr. This is really awesome. You know, and zero deflection cutting through this big ball bearing. Here's a whole bunch of the items. Graphite, hardened steel. This is the DIY machine that he went ahead and put together. He released that video just not too long ago, so you may look back just a little bit in his on his YouTube page to look for this one. It's really neat. This is by far one of my favorite examples of what's possible with wire EDM. This is a 2-stage flexure. You can see it articulating so perfectly. And this is a device that'll never wear out. This was designed by Mike over at BaxEDM. Really awesome. The essential piece of equipment that made all these cutting examples possible is this Arc Generator, the BX17, manufactured by BaxEDM. Hey guys, I'm super excited to share with you a new project I'm starting up. It's a wire EDM machine. I'm not sure how much detail I'm going to get into. That really depends on you guys. I'm going to go ahead and monitor the comments and, you know, how many likes and views the video gets. If it gets enough, I'll put a ton of detail in if that's what you guys want. Otherwise, I'll make it more brief, but it's something I'm really super stoked about. Now, I just received this box here. We'll do an unboxing of this, but this is kind of the heartbeat of the machine, and this is an Arc Generator that a buddy of mine, Mike Bax from BaxEDM, is producing. A little bit about Mike. He's a product architect for one of the large electronics companies. Super talented guy. One thing about Mike, he doesn't only have the electromechanical design skills, but he's also extremely talented with software and programming. And once you take a look at this, the hardware in itself is impressive, the circuit boards that he's put together, but he's got thousands of hours just in the programming and software end of it, which is you know, really all the heavy lifting's been done. I verified my design, which he's helped me with, and I'll take you into Fusion 360. We'll take a look at the model and show you what I've got in mind for my machine. So there's really 4 major parts. You've got the mechanical XY CNC stage part of the machine. You've got the wire handling, which is what we're referring to as the C-arc. It's got the wire feed speed, and then it has tension that have to be considered. Another big issue is the water, the fluid that you basically cut in a bath of water. And that's quite an elaborate system in itself. And then the final stage, which is something Mike's done an excellent job with, is the actual programming and software of the controller. Many of you have followed along on my Instagram. I share a lot of my projects, and you guys, a lot of you have seen this 6-axis robot arm that I entirely 3D printed on the BerryBot 3D machine. And this is an amazing piece of kit. Many of you know Chris Annans, a buddy of mine, spearheaded this project, and another brilliant engineer. I make it a habit of associating myself with these guys and learning as much from them as I can. This is another project that's coming down the pike where I'm building another one of these all out of aluminum. I've still got a few parts to machine up, but it's going to be another really fun project. So you guys that have been interested in that, I know you're going to really love following along with this project. And keep in mind, even if this is not something you could see in your future, much of the electrical control systems and whatnot are applicable to just about any CNC machine build that you might do, whether it's a hobby mill, a CNC retrofit, or a CNC router, or even a little hobby CNC router. A lot of the things that we're going to be doing are applicable to those applications as well. So I hope you guys get as excited about this as I do. We'll fire up Fusion. I'll show you what my design's all about, and we'll have some fun. Well, here we go, guys. I've got Fusion fired up, and this is what I've got in mind for my EDM machine. The beauty of this machine is it's fully capable. I mean, you can cut 2-inch thick stock, no problem. However, it's just a fraction of the size of a commercially acquired machine. This is actually designed to be put right onto a desktop. Now, there's still quite a few components in the way of water filtration and the water handling, which is going to take up quite a bit of space, but that's those are all separate components, so they can really be pretty much put anywhere. As you can see from the model here, I do plan on using all ClearPath servos. They're really good in the way of suppressing noise. I can give you a close-up view of this XY stage that you see here. This is pretty much the assembly of the XY stage. Now, all of these components, these plates here and these end supports will be machined out of aluminum. And these linear rails and blocks I purchased from AliExpress. Now, I do have about 95% of the parts on hand. There's just a few small things that I still need to acquire, and most of those are from Masumi and from McMaster Car, but are very easy to get a hold of. So you can see in my model, this is the whole tank area here, and then these doors will be openable. And what that'll do is allow me, 90% of the time, this table work surface member will probably be removed. And what it does is it gives you access underneath the part so that you can rethread the wire if necessary. Once everything's dialed in, it's really great and runs really well. But if you're testing new materials or you're trying to push the limits of the machine, that's when you can have wire breakage, and you'll need to go ahead and rethread. I think you can see from the model it is a very compact little system. This is how my C arc is going to be designed. I'm utilizing a Z-axis here, and I have the idea that I could eventually use it for hole popping or even doing sync EDM. I intend to build my own filtration system. This is what I've modeled up. I already have these cartridges, and these are standard cartridges used in the production EDM machines. These two end plates will be machined out of aluminum. And there's another filtration. This will take it down to 5 microns. So this gets most of the particulates out of the water. It'll go from here into another unit that looks almost identical to this. It's just a little bit smaller. And it goes through a 1 micron sediment filtration system. So once it goes through these filters, it'll go into the main reservoir tank that'll hold about 50 gallons of water ready for use in the EDM tank. So I'll actually have 2 main tanks. One's the dirty water that's collecting water straight from the EDM tank. Then it'll go through the filtration system into the clean reservoir tank, which is the larger one. There will be 2 volumes worth of water in the clean tank. And the reason I wanted that is that I can, if I end up dumping the tank, I can instantly refill it. And the way that's going to work is I've got a small 20-gallon tank that's just above, it'll be just behind and above my main EDM tank. And it'll have a vacuum on it, so it can suck a tremendous amount of volume very quickly from the clean reservoir tank into this header tank. And then as soon as the vacuum turns off, within maybe 15 seconds, through a large diameter 2-inch tube, it'll drain into the main tank. That way I can move 20 gallons of water very rapidly. Down in the bottom here, I've got silicone seals. And this is made out of the same cord I use for my vacuum pallet system. This stuff is really great. I get it through McMaster Car, and it's actually an open cell, but it has a skin on the outer surface, which makes a very nice seal. And it is 100% silicone, and you can bond it to itself using an RTV silicone, and it works really, really well. You can take a look here. This is a exploded view of how the cup assembly works. This clear cup that you see here is actually called a flush cup. And this is what directs the water right through this nozzle right here, which is, on my machine, I'm going to start off with a 2mm nozzle. This flushes both the top and the bottom, and basically gets the debris out of the curve that the wires just cut. This cup right here, the smaller one, is considered a wire guide. Both the wire guide and the flush cup are common parts that you can get for production machines. I will be machining this part here out of 303 stainless. Here's a detailed view of my tank design. This right here, what happens is this will fill up with water and have a constant flow of clean water coming into the tank. It'll fill up to a point that can be adjusted so that you can adjust the level of the water in this tank based on the thickness of the part that you're cutting. And what you can do is you can slide this collar up on the top, which will adjust this opening in these two slots, which gives you some adjustability as to how much water is in the tank. Now, when the water fills up, it can also overflow in the case that something was to happen. This is an emergency overflow so that it would instantly drain. This right here is a 1.5 by 1.5 304 stainless structural tube that'll run across this area here. This is where the two doors will make a seal. The reason for this tube here on the back is because I have a Teflon liner that runs across here and down this wall. It's got a little weight on it to pull the... You can see it here. Here's the Teflon material. It'll have a little counterweight here to draw it down, but this will slide back and forth to help protect any moisture or water droplets from getting on my rail system. I'll probably end up 3D printing a guard for this too. This linear rail here came from Masumi, and this is all stainless steel. The block rails and bearings are all stainless. Although much of the machine will be stainless steel and aluminum, there will be some 3D printed parts. For example, I just modeled up this piece right here, which is going to house a die-cast aluminum project box. This is going to have a circuit board that Mike has designed and put together that basically handles the control for this is the wire feed speed servo over here on this side, and this is the take-up tension servo over on this side. And so there will be a controller here that handles this system. So I'll go ahead and 3D print this out of PLA. The rigidity of PLA makes this kind of thing very easy to do and works excellent. One other aspect of this tank design is that this articulates up and down. It's got an air cylinder here on the back. And what will happen is this will articulate up and down to allow water to exit through this very large 2-inch diameter opening. That should allow for a really rapid draining of the tank. One other point I wanted to make is that these things down here is a gutter system I designed to allow the doors to be opened, and should water, which it surely will, be dripping off of the seal, it'll land into this trough and drain down into this one here, which will come out here and go back into the dirty tank. Likewise, this door has the same type of system. Now, I do intend to make these parts out of 3D printing these out of PLA. I could certainly bend them out of stainless sheet metal, but this is a perfect opportunity to make parts out of 3D print parts, try them out, and I'll go ahead and lay a piece of 3/4 ounce fiberglass cloth on the inside edge of this. It'll be totally waterproof and work really well. Should I want to do other iterations of it, it's just a piece of cake. Model it up, 3D print it, and there you go. As I progress through the build, I will go ahead and supply you with the people that I've ordered parts from. For example, these AliExpress parts. I spent quite a bit of time to find a really good, reliable supplier for these parts. And I think it's really important, you know, to be able to pass that along to anybody else that's going to build something like this. Everything that I've received so far has been really excellent quality, and I'm really happy with the parts. The sheet metal for this tank I will be fabricating out of 304 stainless sheet that is 10 gauge. So it's pretty stout material, and will allow very easy welding on these couple of seams. Although there's a lot of fabrication to this project, things like the feet, these hinges, and this latch are coming from McMaster Carr. Other parts like these toggle clamps are coming from Masumi. Many of the things like these gears here are stainless gears that came from Masumi. Some of the more complex parts that I will have to machine by lathe are these stainless steel rings, which are isolated. The blue that you see on these rings here are to isolate this stainless steel from the gear. Likewise, many of these pulleys have ceramic bearings. The ceramic bearings help isolate because the wire is going to be guided through this groove right here. It's electrically charged and has to be isolated from the rest of the frame. This unit right here will be a flexure. It's got super fine thread. It's like 80 threads per inch on these two thumb screws, which will allow flexing to get perfect location of this upper wire guide to the lower wire guide. Well guys, I hope you enjoyed looking at my model and my plans to build a wire EDM machine. Please leave notes in the comments. Let me know what your ideas are. Okay guys, I'm super excited. This is my first and maybe my only ever unboxing video of the Arc Generator that was sent to me from Mike at BaxEDM. So we'll open it up here and see how good a job he did packing it. I was a little worried about getting this shipped over here. This is coming from the other side of the world, and it's a little pricey, you know, for a piece of kit. Probably one of the more expensive things I bought for a build. But this is something I've wanted for a very, very long time, and I'm just super excited to get this going here. Looks like we got some paperwork in here. Oh, this is really cool. This has got a pass and fail. Whole bunch of different items checked off here for pass or fail. So that's really cool in my invoice. And just so you know, I did purchase this. And here we got, looks like a lens. This is for the light. Now this had an optional accessory kit. This is all the bits and bobs to hook it up. I went ahead and purchased this as well. I thought it was pretty reasonable for what you get. And the tricky thing about this, and we'll get into this, but it's this cable right here. From what I understand, this is very special stuff. And we'll open that up here in a second. We'll pull this guy out. Man, he did a great job packaging this. I shouldn't have had any concerns. He did a super job with this high density foam here. It's got nice space all the way around the box. So super good job, Mike. Go ahead and pull that out. Yeah, this is very, very well done. is the unit right there. The heartbeat of an EDM machine. And yeah, very nice. And here's a look at all the connections on the back. Mains, and this goes out to power the wire. This is data communications. I think this is for a light. I'm not sure what that one's for. But anyway, we'll put this off to the side and we'll get into some of these goodies. So this is the cable that, from what I understand, is very special and apparently very difficult to get a hold of as well. So that just looks like regular hookup cable there. And here's a whole bunch of special items. This is for the power to the wire, the connector for it. And Mike has done a really good job on his website. He pretty much goes through a lot of the hooking up of the machine, and with a lot of detail. Just about everything's there. I've spent hours and hours digging through his website, and you know, I've had questions, and almost everything I can find the answer on the website. This is a differential converter that he's put together, again, just to make the whole process of hooking this up easy. But yeah, this is great. These are special in that they're all the shells for the plugs are shielded. As you probably can imagine, this is a major noise generator, so keeping everything shielded is of utmost importance. Anyways, guys, that's my unboxing, and eventually we'll go through installing every single one of these components, and it's going to be super exciting.